Understanding the differences between electronic ballasts is crucial for properly wiring emergency lighting. Firstly, let's consider the instant start slimline ballast. This type of ballast provides a high voltage pulse to ignite the lamp instantly. Secondly is the rapid start ballast, which uses a low voltage starter to heat the lamp's cathodes before applying the high voltage. Thirdly, we have the lead lag instant start slimline ballast. This is similar to an instant start ballast, but uses a two-stage ignition process to reduce flicker and extend lamp life. Now let's discuss the voltage on the leads. Typically, yellow and blue wires are connected to the line voltage, which is either 120 volts or 277 volts, depending on the ballast. The black and white wires are connected to the lamp and typically carry between 120 volts and 240 volts. If you're looking at a diagram, and diagram C seems correct, it likely shows the wiring for a lead lag instant start slimline ballast. The dual light name refers to the emergency ballast with dual output sockets for two lamps. Understanding the significance of the wire colors is essential. Yellow wires usually indicate line voltage, either 120 volts or 277 volts. Red wires are typically connected to a common point, often connected to both sockets. Blue wires are connected to the lamp and carry voltages between 120 volts and 240 volts. Blue and white wires are usually connected to the neutral, which corresponds to the white wire in the power supply. Yellow and black wires typically connect to ground, which is connected to the green wire in the power supply. Let's delve into the theory and inner workings of these ballasts. Instant start ballasts apply a high voltage pulse, ranging from 1500 volts to 3000 volts, to the lamp's electrodes, causing a spark that ignites the lamp. Rapid start ballasts use a starter to heat the lamp's cathodes to a point where they emit electrons. Once sufficient electrons are emitted, a high voltage pulse is applied to ignite the lamp. Lead lag ballasts employ two transformers, a lead transformer to provide the high voltage pulse for one lamp, and a lag transformer to provide it for the other lamp. This delays the ignition of the second lamp, reducing flicker. Looking at a typical wiring diagram such as diagram C, the yellow and blue wires are connected to the line voltage, either 120 volts or 277 volts. The red wire is connected to the common terminal on both lamp sockets. The blue wires are connected to the lamp terminals on both sockets. The blue and white wire is connected to the neutral, white wire in the power supply. The yellow and black wire is connected to the ground, green wire in the power supply. In summary, when installing emergency lighting, firstly, identify the type of ballast you are working with, whether it is instant start, rapid start or lead lag. Secondly, understand the voltage levels on the different colored wires, paying close attention to the yellow, blue, red, blue and white, and yellow and black wires. Thirdly, carefully follow the wiring diagram specific to the ballast model to ensure proper and safe installation. Remember that instant start ballasts use a high voltage pulse for ignition, rapid start ballasts preheat the cathodes, and lead lag ballasts use two transformers to minimize flicker. Always verify the voltage levels with a multimeter to ensure correct wiring. When connecting the wires, firmly secure each connection to prevent loose connections and potential hazards. After wiring the emergency lights, test them to ensure they function correctly during a power outage. Familiarize yourself with local electrical codes and regulations related to emergency lighting. Understanding these principles is essential for safe and effective emergency lighting installations. For example, in an instant start system, the ballast delivers a substantial voltage spike to the lamp which initiates the arc immediately. This method is energy efficient but can sometimes shorten the lamp life due to the stress of the high voltage ignition. On the other hand, rapid start ballasts offer a more gentle ignition process by preheating the lamp electrodes before applying the full voltage. This preheating extends the lamp life and ensures a more reliable start, especially in colder environments. Lead lag ballasts, commonly used in pairs of lamps, incorporate a lead circuit for one lamp and a lag circuit for the other. The lead circuit provides a higher current initially, while the lag circuit slightly delays the ignition of the second lamp, balancing the load and minimizing flicker. These ballasts are slightly less energy efficient due to the additional components, but they provide superior performance in applications where flicker is a concern. Wire color codes are crucial for proper wiring, and strict adherence is required. Yellow wires consistently represent the primary line voltage input to the ballast, whether it is 120 volts or 277 volts. Blue wires are always associated with the lamp connections, typically carrying between 120 volts and 240 volts. Red wires indicate the common connection point, which serves as a shared electrical reference for multiple components. Blue with white stripes signifies the neutral connection, which is tied to the building's neutral bus and provides a return path for the electrical current. Yellow with black stripes represents the equipment grounding conductor, providing a safe path for fault currents to the ground. When replacing a ballast, carefully note the existing wiring configuration. Disconnect the power supply and verify that there is no residual voltage before proceeding. Match the wire colors of the new ballast to the existing wiring, ensuring that each wire is securely connected using appropriate wire connectors. Always consult the manufacturer's instructions for the specific ballast you are installing. Incorrect wiring can lead to ballast failure, lamp damage, or even electrical hazards. Testing is a critical step after completing the wiring. Restore the power supply and observe the lamps to ensure they ignite properly. Simulate a power outage by disconnecting the main power source to the emergency lighting circuit. Verify that the emergency lights switch on automatically and provide adequate illumination. Walk through the lit area to assess the light distribution and identify any potential issues. It is important to check the backup power source, typically a battery or generator, to ensure it functions correctly. Regularly test the emergency lighting system to ensure it remains operational. Consider the specific application when selecting a ballast type. For example, in areas where energy efficiency is paramount, instant start ballast might be the preferred choice. In areas where lamp life and reliability are more critical, rapid start ballasts could be a better option. Lead lag ballasts are well suited for applications where flicker reduction is essential. Proper ventilation around the ballast is necessary to prevent overheating. Do not install ballasts in enclosed spaces without adequate airflow. Periodically inspect the ballasts for signs of damage, such as cracks, leaks, or discoloration. Replace any damaged ballasts immediately. Familiarize yourself with the National Electrical Code (NEC) requirements for emergency lighting systems. The NEC provides detailed guidelines for the installation, wiring, and maintenance of emergency lighting. Understanding these requirements is crucial for compliance and safety. Many modern ballasts incorporate electronic circuitry that optimizes lamp performance. These electronic ballasts offer improved energy efficiency, reduced flicker, and enhanced lamp life compared to older magnetic ballasts. When replacing an older magnetic ballast, consider upgrading to an electronic ballast to improve overall system performance. Always wear appropriate personal protective equipment (PPE) when working with electrical systems. This includes safety glasses, insulated gloves, and appropriate clothing. Never work on live circuits. Always disconnect the power supply before working on any electrical equipment. If you are not comfortable working with electrical systems, consult a qualified electrician. Emergency lighting is a critical safety feature that can save lives during power outages. Proper installation, wiring, and maintenance are essential to ensure the system functions correctly when needed. Before doing anything, consult the National Electrical Code Article 700. It covers emergency systems which are essential for safety of life. These systems must be able to reliably supply illumination and power during power outages. The code specifies the sources of power, transfer equipment, and circuit wiring. Emergency systems must be arranged to automatically supply power to required loads within 10 seconds of a power failure. The code also dictates regular testing and maintenance of the system to ensure reliability. Also, the NEC Article 701 covers legally required standby systems which are essential for business continuity. These systems supply power to loads such as heating, ventilation, communications, and signaling systems. While not directly intended for life safety like emergency systems, they prevent disruption to businesses and public services during outages. Legally required standby systems must be able to supply power within a specified time, usually within 60 seconds after a power failure. The code mandates regular testing and maintenance of these systems as well. NEC Article 702 covers optional standby systems which are designed to provide power to non-essential loads. These systems are installed at the owner's discretion to improve convenience or productivity. Optional standby systems may supply power to loads such as lighting, heating, or equipment. The code does not require these systems to have automatic transfer capabilities, but the requirements for wiring and overcurrent protection must be adhered to. It is critical to follow the NEC guidelines and safety precautions when working with electrical systems. Electrical work should be performed by qualified individuals who understand the risks involved. By following the code and implementing safety measures, electrical systems can be installed and maintained safely and effectively. Additionally, note that emergency lighting circuits must be independent of general lighting and power circuits. This segregation ensures that a fault on a regular circuit will not affect the operation of the emergency lights. The wiring for emergency circuits should be mechanically protected to prevent damage. Use rigid metal conduit or other approved wiring methods to safeguard the conductors. Emergency lights should be positioned to provide adequate illumination along exit routes, stairwells, and other critical areas. Consider the layout of the building and the potential for obstructions when determining the placement of the lights. The intensity of the light provided by emergency lights must meet minimum requirements specified in the building code. Use luminaires that are listed and labeled for emergency lighting applications. The battery backup system should have sufficient capacity to power the emergency lights for the duration specified in the building code, typically 90 minutes or more. Regularly inspect the batteries for signs of corrosion or damage. Replace the batteries as needed to maintain the system's reliability. Emergency lighting systems should be tested monthly to verify their operation. Simulate a power outage and observe the lights to ensure they switch on automatically. Keep a record of the test results and any maintenance performed. Building codes may require additional features such as remote monitoring or automatic testing capabilities. Be aware of the requirements in your local jurisdiction. Emergency lighting is an integral part of a comprehensive life safety plan. Work with qualified professionals to design, install, and maintain a system that meets your specific needs. Be sure to coordinate the emergency lighting system with other life safety systems such as fire alarms and sprinkler systems. A properly designed and maintained emergency lighting system can significantly improve the safety of building occupants during a power outage. In summary, the key differences between instant start, rapid start, and lead lag ballast lie in their ignition methods and performance characteristics. Instant start ballast offer energy efficiency but may reduce lamp life. Rapid start ballasts provide gentle ignition and extend lamp life. Lead lag ballasts minimize flicker but are slightly less energy efficient. Understanding these differences is crucial for selecting the appropriate ballast for a specific application. The NEC guidelines are essential for ensuring the safety and reliability of emergency lighting systems. Proper wiring, regular testing, and adherence to code requirements are critical for protecting building occupants during power outages. When troubleshooting lighting issues, consider several potential causes. Firstly, check the lamp itself. A burned-out lamp is the most common reason for a light not working. Replace the lamp with a new one of the correct type and wattage. Secondly, examine the ballast. Ballast can fail over time, especially in older fixtures. Listen for humming or buzzing sounds, which can indicate a failing ballast. Use a multimeter to check the voltage to and from the ballast. If the ballast is faulty, replace it with a new one of the same type. Thirdly, inspect the wiring connections. Loose or corroded connections can prevent the flow of electricity. Tighten any loose connections and clean any corroded contacts. Fourthly, check the switch. A faulty switch can prevent the light from turning on. Test the switch with a multimeter to ensure it is functioning properly. Replace the switch if necessary. Fifthly, look for any tripped circuit breakers. If the circuit breaker for the light is tripped, reset it. If the breaker trips repeatedly, there may be a short circuit in the wiring. Sixthly, consider voltage fluctuations. Inconsistent voltage can cause lights to flicker or not work properly. Use a voltage meter to check the voltage of the light fixture. If the voltage is too high or too low, consult an electrician to correct the problem. Also, check for any signs of damage to the fixture. Cracks, dents, or water damage can compromise the fixture's safety and functionality. Replace any damaged fixtures. Be sure to keep records of all maintenance and repairs. This will help you track any recurring issues and prevent future problems. A systematic approach to troubleshooting can help you quickly identify and resolve lighting issues. By following these steps, you can ensure that your lights are working properly and safely. Also remember to always disconnect the power before working on any electrical equipment. This will help prevent electrical shock. Use insulated tools when working with electrical equipment. This will further reduce the risk of electrical shock. Never work on electrical equipment in wet or damp conditions. This greatly increases the risk of electrical shock. If you are not comfortable working with electrical equipment, consult a qualified electrician. Working with electricity can be dangerous, so it's important to take all necessary safety precautions. By following these guidelines, you can safely troubleshoot and repair lighting issues. Consider implementing a preventive maintenance program for your lighting systems. This can help prevent problems before they occur and extend the life of your lighting equipment. A preventive maintenance program should include regular inspections, cleaning, and testing. By following a preventive maintenance program, you can ensure that your lighting systems are always working properly and safely. The selection of the right type of ballast is critical for the performance and longevity of the lighting system. Consider the specific requirements of the application when choosing a ballast. The electrical characteristics of the ballast must match the electrical characteristics of the lamp. Using an incompatible ballast can damage the lamp or the ballast. The ballast must be properly rated for the voltage and current of the circuit. Using an undersized ballast can cause it to overheat and fail. The ballast must be installed in a location that is well ventilated. Overheating can shorten the life of the ballast. The ballast must be protected from moisture and other environmental factors. These factors can damage the ballast. The ballast should be inspected regularly for signs of damage. Damaged ballast should be replaced immediately. Consider the energy efficiency of the ballast when making your selection. Energy-efficient ballasts can save you money on your electricity bill. There are many different types of ballasts available, so it's important to choose the right one for your needs. Consult with a lighting professional if you need assistance selecting a ballast.